Hello, I'd like to talk a little bit about inverse functions and how to find one given in symbolic form. So let's say we have f of x equals the rational function 1 minus x over 2x minus 5. Okay, so I want to find the inverse function for this rational function. So I'll go ahead and assign y, replace f of x with y, and just rewrite on the right hand side. So 1 minus x over 2x minus 5. And then you want to solve for x. So I want to eliminate my denominator by multiplying by the 2x minus 5 on each side. So I have y times quantity 2x minus 5, and when I do that on the right hand side, that denominator will cancel. I'm just left with 1 minus x. Then I want to distribute my y, so where I can get all terms that have an x in them on the same side. So 2yx minus 5y equals 1 minus x. Now I have a term here on the left side with an x, a term on the right with an x. I want to move them to the same side and move all other terms to the other side. So I'm going to move it to the left, add x to each side. So I have 2yx plus x. I'm going to then add the 5y to each side, 1 plus 5y. So it cancels negative 5y on the left and negative x on the right. Then I notice that these, on the left-hand side here, both of these terms have an x in them, so I can factor that x out, which will enable me to solve for x. So x times the quantity 2y plus 1 equals 1 plus 5y. Then last step, solve for x, just undo that multiplication, just divide on each side by the 2y plus 1. And then I have my x solving for x, so the mapping has switched. Right now I get my x coordinate by plugging some value in for y, maps to the x, instead of x mapping to y, which is what an inverse is. And that's that's what my math lab calls the f inverse y, and that's the way you'd answer it in terms of y's instead of x's. But normally, in a lot of other textbooks, and normal convention is to, at the end, rename, swap the variables, and then rename this f inverse of x. If I reverse variables, then I have 1 plus 5x over 2x plus 1. So we're just switching x's and y's, switching place. And there's your inverse function. I'm going to go ahead and do one more example of finding an inverse function from a given function symbolic form. So second one here, let's say we have f of x equal to 2 times 3 to the x minus 1 power plus 5. Okay, so I want to find the inverse function for this transformed exponential function. All right, fix it a little bit. So, same procedure, replace f of x with y. Then I want to isolate the exponential expression, the 3 to the x minus 1. I want to get that by itself. So I'm going to subtract 5 from each side. And then divide by 2 on each side. And then how do I solve for a variable? Solve for an exponent expression? Use a logarithm, right? So rewrite this in logarithmic form because it's now exponential form. So log base 3, it's the same base as we have, of this whole left-hand side, the output of the exponential, is what I'm putting into the logarithmic expression. equals my exponent, x minus 1. Because a logarithm is really just an exponent. In this case, the exponent x minus 1. And last step's to add 1 to each side. So I have log base 3 of the quantity y minus 5 over 2 equal, plus 1. Plus 1 equals x. And then we rename that f inverse of x, reverse the x's and y's, that's my new y, and now replace the left-hand side, replace y with x. So log base 3 quantity x minus 5 over 2 plus 1. And there's your answer. So always the inverse function to an exponential function is some form of a logarithmic function. They're inverse functions.